Welcome back to Jake's Amp Garage. And on the bench today we got something other than a guitar or an amp. I thought you guys might find this interesting. I'm going to show you in a minute here how this thing works. It's a high voltage resonance pump. Well, that's what I call it anyway. A resonance pump. Works off the main supply, and it has a 24 volt power supply over here, a 24 volt DC controller, a motor, standard 24 volt DC motor, actually 30 volt DC motor, a washing machine drain pump, which puts out about 160 volts RMS or so, that feeds into this neon sine transformer, which gives about 6,000 volts, or slightly more in this case. It's 6,000 volts at 120 volt input. Goes through two spark gaps here. This one's been disconnected, and through an adjustable spark gap, which then after that it goes through this high pressure sodium light bulb. Now I don't actually turn the light bulb on in this configuration, but you can see the electron flow through this inner tube. So I'm gonna set up the cameras again so you can take a better look at it, and then I'm gonna run this thing so you can see what it looks like. See you on the other side. Okay, we're back. So this thing is on standby, as you can see by our neon light there. It's on. It's supposed to be a green light, but it looks yellow for whatever reason. This is our DC control knob, DC motor there, our washing machine drain pump. It's our neon sine transformer here, and our high pressure sodium bulb. You can see the spark gaps all there, and our DC meter over here, or AC meter. That's an analog meter, obviously. The digital ones don't work because this thing puts out a resonance field. Let's call it that. Some people say electromagnetic, but I call it a resonance field, which I've measured from about 2 meters away. I'm not going to do that today. I'm just going to demonstrate how this thing works. So let's crank it up. You guys can see the spark gap here. There it's starting. You can see it. The tube here is starting to flicker. And analog meter there is reading. That's about 50 volts RMS. Let's get this thing going here. What I can smell right now is burning ozone. You can definitely smell it in the air. Let's see if I can get a close up here. Oh yeah, you can definitely smell the ozone right now. Closer you get to those spark gaps. See our reading on the meter over here. It's about 165 volts RMS. I've got some high resolution photos that I took of the spark gap with a digital camera, not the phone camera, an actual proper camera, which I'm going to include in the video. Alright, let's turn that off. There we go. Anyway, I thought you guys might enjoy that, alongside the normal amp and guitar stuff. It's a little project I've been working on for the last 2 years, trying to understand how all of this thing works. My background is in electrical engineering, and some of the stuff that we get taught in engineering or electrical engineering doesn't go to some way to explain how this thing works. Okay. Well, I hope you guys enjoyed that. If you like it, give it a big thumbs up. subscribe. I know it's not part of my normal amp and guitar thing, but I thought you guys would enjoy this. Okay, so long for now. See you on the next one.